Hello everyone, welcome back to Exemplar Physics. In the previous video, we have discussed about the CBSE sample paper for class 10th, subject Science, subject code 086. We have discussed how the questions have been asked, how the questions are divided into several sections, namely A, B, C and D, how the marks are allotted to each question, and also how the marking system will be. And at the end of that video, I have given you some tips for answering and scoring better marks. If you haven't seen that video, I am putting the link at the I button. Please click on the link and watch that video too. In this video, we will be discussing 1 mark questions which have been asked in the section A. So this video will be related to the physics portion of section A. So let's get into the discussion. So the first question in physics is serial number 4. The question is, why does sun appear white at noon? This question has been taken from the second chapter, Human Eye and Colourful World. Human eye has been deleted from the portion, but the colourful world still exists in the syllabus. So this question has been asked from the colourful world. Let us assume this is Earth, a portion of Earth, and Earth is surrounded by atmosphere. So this is the atmosphere. Sun is far away. So this is the sun, and let's take sun at 2 different positions, one at the horizon and 2 at overhead. So at horizon, this could be during morning or evening, and sun overhead, so this could be at noon. The concept which you have to understand here is, when the sun is at the horizon, the rays of the sun have to, so let us assume here is an observer. The rays of the sun has to travel a longer distance in order to reach the eye of the observer. Whereas when the sun is overhead, the rays have to travel less distance. And the another point which you should understand is, the atmosphere near the horizon, is optically denser compared to the atmosphere overhead. By considering these 2 points, when the sun is at the horizon, the light has to travel larger distance and has to pass through an optically denser atmosphere, and because of which it undergoes more scattering. As a result, all the colors except those which are having the higher wavelength, like red and nearby colors, undergo scattering and they get scattered out, and only the red color reaches the eye of the observer. So for him, the sun appears as red. When the sun is overhead, now the light has to travel less distance and has to pass through optically rarer medium. So the light undergoes very less scattering. Only the lesser wavelength part of the light gets scattered over there, and almost all the light enters the human eye or the observer's eye. So the observer can see all the colors coming from the sun. So the sun appears as white during the noon. So the answer you have to write here is this answer you need not have to explain all this. So the question is for just 1 mark. So the answer you have to write here is, I'll write it with the black pen. When sun is overhead during, so sun is overhead during noon. So when the sun is overhead during noon, it has to travel relatively less distance and undergoes least scattering. Hence, all the colors are visible to the observer. So, sun appears white. So, that is the answer you have to write. So, I hope you have understood. Let's go to the next question. The next question which we have here is question number 5. If you have any doubts, please ask in the comment section. I'll surely help. So next question, question number 5. So here is the question. Both a spherical mirror and a thin spherical lens have a focal length of minus 15 centimeter. What type of mirror and lens are these? So for answering this, you should know this concept. So we study for class 10th 2 types of mirrors. One is a concave mirror and the other one is a convex mirror. And in case of lens, we study concave lens and convex lens. So concave mirror, for concave mirror, focus is on the left side of the mirror. So the focal length for concave mirror is, I am writing here the focal length, I am just writing this sign. The focal length for the concave mirror will be negative. For convex mirror, focal length lies on the right side of the mirror, that is positive. Concave lens, focal length, see for lens, the focal length lies on the both sides, but you have to consider that side of the lens at which converging or diverging happens. So in concave lens, the divergence happens due to the focal length on the left side. So the focal length is negative, and for the convex lens, the convergence of the lens takes place because focus on the right hand side. So that is positive. So you can remember like this, if it's a concave, whether mirror or lens, focal length will be negative. You can also remember like this. And if it is a convex mirror or lens, the focal length is positive. So the answer here will be answer. You have to write just in the one word. So the answer for the 5th one will be concave mirror and concave lens. So these are the answers. Here is the question number 6. The image formed by concave mirror is observed to be real, inverted and larger than the object. Where is the object placed? So it's a concave mirror and the image is real, inverted and larger than the object. So we get a real, inverted and magnified image if the object is placed between object, please write it carefully, object placed between focus and center of curvature. Okay, so this is the answer. If the object is placed between focus and center of curvature, the image formed by the concave mirror is magnified. So there is an OR question for the question number 6. The OR question is, name the part of the lens through which ray of light passes without suffering any deviation. So, through which part of the lens when a ray of light passes does not undergo bending or refraction. So, this is the OR part of the question. See, if you see a convex lens or concave lens, so the center point of the aperture given is called optical center. So the aperture is called as optical center. So the point, let me denote it by O. So O is optical center. O is optical center. So when the ray of light passes through this optical center, so it moves undeviated. It moves undeviated. Refraction is not visible. So this is the only point in a lens where the ray undergoes without deviation. So you can't see the bending of light. Let's go to the next question. Question number 7. So at any point of the video, you can pause the video, and if you are noting it down, you can note down. Question number 7. So this has a diagram too. We are doing question number 7. In the arrangement shown in the figure, there are two coils wound on a non-conducting cylinder. So the cylinder is non-conducting. Initially, the key is not inserted in the circuit. Later, the key is inserted and then removed shortly. So please see the diagram carefully. Now the question is, what are the two observations that can be noted from the galvanometer reading? So this question has been directly taken from the NCERT textbook. You have an activity in the topic electromagnetic induction. So please go through that activity. So what do we have here? We have a cylinder, non-conducting cylinder, and above the non-conducting cylinder, what do we have? We have two coils wound over it like this. So one of the coil is having a battery and a switch, and the other coil is also wound on the same non-conducting cylinder, but it has a galvanometer. So let us name the coils. This as coil 1 and this as coil 2. So we have two coils there. So we need to note this following sentence from the text question. Initially, the key is not inserted in the circuit. Later, the key is inserted and removed shortly. Now see that. When the key is not inserted, no current flows through the coil. When no current flows through the coil, no magnetic field is produced in the core. This is core, non-conducting cylindrical tube which we have taken. This is the core. So when there is no current flowing through the coil, no magnetic field, hence this doesn't act like a solenoid, right? So no magnetic field, but as soon as the key is inserted, the current starts flowing through the coil. So as soon as the current starts flowing through the coil, what would happen? Suddenly a magnetic field will be induced because of this coil. Due to this magnetic field, see that initially the magnetic field was 0. Now because I have inserted the key, now I have some magnetic field. So there is some change in magnetic field. So because of this, there is a change in magnetic field from 0 to some value. From 0 to some value. So initial magnetic field was 0. Now it has some value. So what happened? Now let us talk about this coil. Around this coil, initially there was no magnetic field, but as the current flows through this coil, suddenly it experiences a change in magnetic field around it. And because of change in magnetic field, what will be induced? According to the principle of electromagnetic induction, current will be induced. In which coil the current will be induced? Current will be induced in the coil number 2. So current is induced in the coil 2, and see there, because of that current, I'll show the galvanometer here. So let us take this is as a galvanometer. So this is the reading, or you can say scale on the galvanometer, and the galvanometer we will have a 0 at the center. So initially the galvanometer will be indicating 0 due to the presence of no current. As soon as there is a change in magnetic field, the galvanometer needle will show deflection, will move from 0. Now if it moves from 0, what does that mean? The current is induced in this. So that is according to electromagnetic induction. Now this deflection will be momentary. This deflection will be momentary. Why this deflection is momentary? Because when the magnetic field is established around both the coils, especially on the coil 2, and a steady current flows through the coil, so magnetic field will also become steady. So will there be any change in magnetic field? No change in magnetic field. So will there be current induced because of no change in magnetic field? No current will be induced in the coil. So even if the current is flowing for some time now, even though the magnetic field is present around the coil 2, no current will be induced. So this deflection will be only momentary. So you need to note down in which direction this deflects. So that depends upon according to the sense of the coiling. We'll discuss about that later. So if suppose the coil, you have to see that coil deflects towards right or left. Okay, you have to note that. Then what happens? The key has been removed. When the key has been removed, before removing key, what was there? There was steady current flowing through coil 1. Because of the steady current flowing through coil 1, there is a steady magnetic field around coil 2. Now suddenly when the key has been removed, the current flow in the coil 1 becomes 0. So if the current becomes 0, what about the magnetic field created? It becomes 0. So initially there was some magnetic field. Now the magnetic field after remove the key is 0. So there is some change in magnetic fields. So whenever there is change in magnetic field, current will again be induced. But this time you have to note that the deflection in the galvanometer will be exactly opposite. Okay, exactly in the opposite direction when the key was inserted earlier case. Okay, again the deflection will be momentary. So what answer you should write here? You need not have to explain this all concept because this question carries only 1 mark. So what you will see, what you will write, the question is what are the 2 observations that can be noted down from the galvanometer reading? Okay, so what you can note down? You can note down, or you can write this. There are, okay, if you see the question, he is asking 2 observations. So let us number 1, there are momentary galvanometer deflections, okay, and the deflection, second part, second observation, momentary deflection number 1. Second observation, what is the second observation? Deflections will be in, or deflections are in opposite direction, opposite directions. So these are the two observations which you have to write in your answer. Please write them very neatly. Okay. So please refer to the activity 13.8 and 13.9 of the textbook. So this question has been related to activity 13.8 and 13.9. Topic is electromagnetic induction. Very important topic. And the chapter name is, I think I should have told you before answering this, but still, chapter is magnetic effects of electric current. So please go through the activity. The activity is very, very important. Maybe the question may be asked for 3 marks too. So that was question number 7. Let's see the next question. Question number 8. So I'll just first only I'll mention the topic and the chapter from where the question has been asked. Then we can see the answers. So question number 8. Draw the magnetic field lines around a straight current carrying conductor. That's it. You have to draw. So this is from which chapter? Chapter Magnetic effects of electric current. Magnetic effects of electric current. Okay. Magnetic field lines, from the topic magnetic field lines. So you can please draw a current carrying conductor. So I'll draw current carrying conductor with blue. So this is the current carrying conductor. You can draw any direction upward. So this arrow which I have drawn, that arrow shows the direction of the current. You can draw anyhow. So how will be the magnetic field lines? The magnetic field lines will be concentric circles. So I'll draw concentric circles with black color. So black color circles. So yeah, see there, the plane is like this. So if you see from the top, you can see the circles. If you see that from the top, you can see the circles. So we are seeing from a side. Let us say, so the concentric circles look like this. Right? What is the center of the concentric circle? This conductor itself is the center of the concentric circles. And what is the direction of magnetic field lines? The direction of magnetic field lines, you can answer it by using Maxwell's thumb rule. Right hand thumb rule. Maxwell's right hand thumb rule. So what you have to do, take your right hand, okay, in this way, such that thumb indicates the direction of current, then the circled fingers will indicate the direction of magnetic field lines. So in here they are concentric circles. So see that upward is the direction of current, so direction of magnetic field lines. So from this side they are entering into the board. From the other side they are coming out. So this is the drawing which you have to draw, for which you will be awarded 1 mark. Let's see the next question. Question number 9. Here is the question. Question number 9. Two unequal resistances are connected in parallel. If you are not provided with any other parameters, okay, so only resistances are given. Numerical parameters like current, resistance of resistors, etc. What can be said about the voltage drop across the resistor? Okay, you haven't told about any resistance value, but you have to comment on the potential difference across each resistor. So let us take two resistors, unequal resistor. So let us take first one as R1, the other one as R2. Okay, by the way, this is from the chapter Electricity, series and parallel combination of resistors. We have already made many videos on this. So please see the description section for the links of the videos. So see that. So what is the property of parallel combination? The property of parallel combination is potential difference across each resistor remains same. So this is same potential difference. So this is what the answer you have to write in this question. So the potential drop across them is same. You have to comment on the potential drop. Potential drop or potential difference, it means the same. Okay, in the question it has been mentioned as potential drop, so you also write it as potential drop. So the potential drop across each resistor is same. So that is the case for parallel combination. There is an OR question with this. Let's see that question. Some work is done to move a charge Q from infinity to a point A in space. The potential of the point A is given as V. What is the work done to move this charge from infinity in terms of Q and V? So you have to write the expression of the work done in terms of V and Q. So I have a point here, so let's call the point as A, and the charge initially was at very far, at infinity. The charge initially was at infinity, and let us take the charge as Q. So in order to bring the charge from that point to this point, we need to do some work. So that work done, let us write it as W. Now what is the potential at A? Potential at A is given as V in the equation. So what is the work done in bringing the charge Q from infinity to this point? So that is nothing but the product of potential at A and the charge moved. So this is the expression that is required in the answer. So just writing this expression will give you 1 mark. Okay, and this question is taken from the definition of potential difference, right, from the chapter Electricity. So for this definition of potential difference is very, very important. So the next question is question number 19. So question number 19, we have a paragraph and we have multiple choice questions for this, out of which we have to answer any 4. So let's see the question there. Sumati wanted to see the stars of night sky. She knows that she needs a telescope to see those distant stars. She finds out that the telescopes which are made with lens are called refracting telescopes, and the ones which are made of mirrors are called reflecting telescopes. So he is giving us a data there. So refracting telescopes are those telescopes in which lens are being used, and reflective telescopes are those telescopes in which mirrors are being used. So there is a figure 2. So if by seeing the figure you can tell that it's a refracting telescope because lenses have been used. Okay, please see there, eyepiece is the place where you will keep your eye on to watch the stars. So she decided to make a refracting telescope. She bought 2 lenses, L1 and L2, out of which L1 is bigger and L2 is smaller. Please underline that those 2 points. L1 is bigger and L2 is smaller. Please underline those 2 points. The larger lens gathers and bends the light while the smaller magnifies the image. So the function of the larger lens is to gather more amount of light and bend towards the smaller lens. And the property of the smaller lens is to, or the function of the smaller lens is to magnify it. Big, thick lenses are more powerful. So to see far away, she needs a big, powerful lens. Unfortunately, she realized that a big lens is very heavy. So lenses are hard to make and difficult to hold in the right place. Right? Heavier the lens, it is difficult to it is difficult to hold or place them correctly, and even manufacturing them is difficult. So since the light is passing through the lens, the surface of the lens has to be extremely smooth. Any flaws in the lens will change the image. It would be like looking through a dirty window. If the lens is not smooth, then the image which you are seeing won't be clear. So that was your paragraph. Now let's see the questions. Based on the diagram shown, what kind of lens would Sumati need to make the telescope? Right? So by the figure, in the figure, so this is question number 19.1. So please write in the margin 19.1 of your answer sheet if this is your question paper. So based on the diagram, you can see both the lenses are, the bigger one is L1, the smaller one is L2. Both the lenses are convex. Both the lenses are convex. So which of the option is correct? B option is correct. No need to draw, no need to write anything. You have to just mention the B option. And if possible, you write there B convex lenses. Next, the power of the lens L1 and L2 are in the ratio 4:1. So let me write the data 19:2. Okay, 19:2. So the power of the lens are in the ratio of 4:1. Okay, lenses L1 by L2. So let me write the power of the lens of L1 as P1 and the power of the lens L2 as P2. So the ratios are 4:1. So obviously the bigger lens have to have more power because it is converging a large quantity of light. What would be the ratio of focal length? So this is from the lens chapter, right? The power of the lens. So if you know the formula of power of the lens is equal to 1 by focal length, and this focal length should be in meters. Okay. Meters. So P1 is equal to, how can I write P1? P1 is equal to 1 by F1, focal length of the first lens, and divide P2 will be, I can write it as 1 by F2. I can write that as 1 by F2, 1 by F1, 1 by F2. Right? So this is equal to F2 by F1. So what is the value of P1 by P2? Well, the value of P1 by P2 is 4:1. And what is required in the question? Be careful there. What is asking? Then the ratio of focal length of L1 and L2. So ratio of focal length of first should be of the lens L1. So the numerator part will be F1 and then L2. So the denominator part will be F2. So what would be the ratio? 1 by 4. Just be careful while marking the answer. Read the question twice. So the answer would be 1:4. Option B. If you have any doubt, please write it in the comment section. I'll surely help. Please don't hesitate to ask questions. So let's see the third question. You can pause the video at any time and you can note it down. Let's see the next question. 19.3. 19.3. What is the formula for magnification obtained with the lens? Okay, so he is asking formula for magnification. So whether it is lens or whether it is mirror, if you are writing the magnification in terms of the object height and image height, so magnification is always the image height by object height. Okay, so H2 is what? Image height. I always write H2 as image height and I write H1 as object height. So magnification is always image height by object height. If the image height is smaller than the object height, the magnification is less than 1. If the image height is larger than the object height, magnification is greater than 1. If both are equal, then magnification is 1. That is the case in case of a plane mirror. Now see the options. Option A, ratio of height of the image to height of the object. Yes, correct. Height of the object to height of the image. The third one answer is height of the image to height of the object. So third one answer is A. B, double the focal length. We can't say that. Inverse of the radius of the curvature? No. Inverse of the object distance? No, never. So let's see the fourth question. Question number 4. Fourth of the same paragraph. So there will be 5 questions and you need to answer 4. Any 4. So whichever best 4 you know, please answer those 4. Sumati did some preliminary experiment with the lenses and found out that the magnification of eyepiece L2 is 3. Magnification of eyepiece L2. So let us write it as M2. For lens L2, M2 magnification. And what is that? 3. Greater than 1 magnification happened. And if in her experiment with L2 she found that the image at 24 centimeter from the lens. So the image is at 24 centimeter from the lens. What is the distance? At what distance did she put the object? At what distance did she put the object? So the image is formed. So image formed, we'll write it as V here. Image formed is V. So we need to find out U. Okay. So let us try to understand first. Okay. So I'll draw the figure once for solving this question. So see that I'll not draw too much. So this is the smaller lens and this is the larger lens. Let's say they are on the same axis, straight. They are on the straight. It may not look to you as a straight, but say assume that as a straight. Now see what is the source of the light? Source of the light is the stars, right? And the light would be coming from which side? Right side. But according to the convention, we have to take it from the left side. But in this case, if the eye is on this side, if the eye is in this side, so this is the eye. So the stars far away from far right, so the light is entering the lens from far right, Now it refracts at the larger lens. Then what would happen? They will converge at some point. So there they are meeting. So the image of the stars are formed here by lens L1. And this image is nothing but the object for lens L2. So this point, let me write it as M. This point is image for L1, image formed by L1, but object for L2. Then what would happen? So the rays again undergo refraction at L2, right? It will undergo refraction at L2. They should not be parallel, okay? They should meet where the viewer is located. So they should meet where the viewer is located. So where the viewer is located, the viewer is at 24 centimeters on the left of the second lens, right? And where is the object? We don't know, so we'll take the object as U, right? Now the question is, how will you take the conventions here? You have to take the conventions in order to solve the question. So how would you take the convention, right? So first of all, so what shall I take here? I am taking the same conventions if the object image is, if I am measuring image distance on the left hand side, if I am measuring the distance on the left hand side, then I have to measure from the optical axis, right? I have to measure from the optical center. So if I am measuring from the lens towards the left, I am taking that as negative. And if I am measuring the distance from optical center towards right, I will take that as positive. Okay, so I am taking all the distances measured towards left as negative and all the distances measured towards right as positive. So this 24 centimeter is measured from which direction? Towards which direction? Towards the left direction, right? Towards left direction. So V, I will take it as minus 24. And now you see that this M2 is what? Magnification by the lens 2. And this magnification will form a real image or virtual image. They will converge near the eye. So the image formed should be real image. So magnification of real image is minus 3. So what is the formula in terms of object distance and image distance? M2 is equal to V by U. So we can write it as minus 3 is equal to minus 24 by U. So U is equal to minus 24 by 3, minus 3. So equal to 8 centimeters. So I am measuring distance on the right hand side. So the distance of the object distance should be positive. So see that positive distance came. So where is the object kept? The object is kept at M, which is 8 centimeter towards the right of the lens L2, and this object is nothing but image formed by lens L1. If you have any doubt, please write it in the comment section. You can mention the time where you can mention the time of the video where you are facing the difficulty. I'll explain. So I am sure you have understood this, and don't get confused why U is positive. It should always be negative. Okay, see that the distance I have taken on from the optical center of L2 towards right. So distance has to be positive. So that was question number 4. So again, this is from the lens, right? We have used a magnification formula here, and also the signs of convention. So that was the 4th question. And the last question of this paragraph, you have to answer any 4 out of 5. So please answer those 5 questions which you are most confident about. Question number 5. Sumiti bought not so thick lenses for the telescope and polished them. Okay, she's very practical girl. So she didn't buy very thick lens. So what did she do? She bought not so thick lenses of the telescope and polished them. What are the advantages, if any, would have with her choice of lens? So what would be the advantages or benefits for using not so thick lens? Now let's see the options. She will not have any advantage in even thicker lenses would have the clearer image. So that's not right. Okay, if she is using a lighter lens, what is the advantage? The lighter lens easy to handle. Okay, the cost of the lens will also be less. Right. Next, thicker lens would have made the telescope easier to handle. No, thicker lens will make It's very difficult to handle the telescope. So B is not correct. Next, not so thick lens would not make the telescope very heavy and also allow considerable amount of light to pass. Yes, C option is correct. Okay, for now I think C option is correct, but I'll decide after reading the option D. Not so thick lens would give her more magnification. No, that's not correct. So I will fix with option C. So the answer is option C. So that was your paragraph. Next you have another paragraph at question number 20. Okay, see there, after writing the exam, okay, you'll get a, if you have really studied and if you understand the concept, what I'm saying is, if you have really prepared for the exam and you have studied the concept for the sake of learning, then you will really enjoy answering the question paper. Okay, you'll feel the sense of satisfaction after the exam. So let's see the paragraph, question number 20. So question number 20 consists of a paragraph and it would have 5 questions, out of which you have to answer 4. All the questions will be MCQs. Let's see the paragraph. A solenoid is a long helical coil of wire through which a current is run in order to create magnetic field. The magnetic field of the solenoid is the superposition of field due to current through each coil. So it is better to underline this line. The magnetic field of the coil is the superposition. That means the magnetic field of one coil will be say this is a solenoid. So this is core of a solenoid, and so this is the turns on the coil on the solenoid. So let us assume the magnetic field created because of turn 1 is B, turn 2 is B, turn 3 is B, turn 4 is B, and so on. So what is the effect of net of each magnetic field? So according to superposition, the net of magnetic field will be summation of each individual field. So if you have made n turns, so the magnetic field will be n times. So that is what he meant to say that. The magnetic field of the solenoid is the superposition of the field due to current through each coil. It is nearly uniform inside the solenoid. Okay, magnetic field, he is talking about the magnetic field inside the solenoid. How do we draw that? We draw parallel rays of lines of field. That means a uniform magnetic field. And close to 0 outside. Yes, outside the solenoid, what is the magnetic field? See that outside the solenoid, the magnetic field lines are dispersed around the solenoid. So what is the effect of each field line? The effect of each field line will be very, very negligible. So he is saying that it is close to 0 outside and is similar to the field of a bar magnet having north pole at one end and south pole on the other, depending on the direction of flow of current. Correct? The magnetic field produced in the solenoid is dependent on few factors such as the current in the coil, number of turns per unit length, etc. The following graph is obtained by the researcher while doing the experiment to see the variation of the magnetic field with respect to current in the solenoid. The unit of magnetic field is given in the graph attached to MT. MT is millitesla. Okay, MT is millitesla. And the current is ampere. So let me draw the graph for you here. So that would be a reference for you. Okay, so let's draw the graph. So x-axis is current and y-axis is magnetic field. And what is the unit of magnetic field? Millitesla. Unit of current, ampere. Now let me draw the graph there. So graph is a straight line. So you can see here 0.2, 0.4 and so on. So this is the point 8 according to the graph, and at the same time the corresponding magnetic field is 13 millitesla. 13 millitesla. So this point is 13 millitesla. See there, according to the graph, the magnetic field is directly proportional to current. So we got the graph shows it's a straight line. So let's see the question. Question number 21. What type of energy conservation is observed in a linear solenoid? Okay, so linear solenoid is a solenoid which is straight. So there are other types of solenoid. You can change the core and you can make many shapes. Okay, you can make a toroid if it's a complete circle. You can make U shape. Lot of shapes you can make. It's very easy with solenoid. So what type of energy conservation is observed? Energy conversion is observed in a linear solenoid. So option A, mechanical to magnetic. Option B, electrical to magnetic. Option C, electrical to mechanical. Option D, magnetic to mechanical. So when you are passing the current through the solenoid, what is happening? Magnetic field is created. So what type of conversion takes place? The conversion is from electrical to magnetic. So this is the conversion taking place here. So the answer is not option A, option B. Option B. Answer is option B. See the next question. 22. What will happen if a soft iron bar is used inside the solenoid? Okay, so soft iron bar, what would it do? It would allow more magnetic field lines to pass through it. So what would happen? Magnetic field will increase. So let's see whether that is there in the options or not. Option A, the bar will be electrocuted, resulting in short circuit. Okay, see the wire which we are using here should be insulated copper wire. If you are not using insulated copper wire, then the bar and the wire may get shorted. Wire between each and every turn may get shorted. So since we have to use insulated copper wire. So even if you are using a soft iron, that will not get electrocuted. Option B, the bar will be magnetized as long as there is a current in the circuit. Correct. B is correct. But I am not locking the answer until I read all the options. Option C, the bar will be magnified permanently. No, that is not correct. Option D, the bar will not be affected by any means. No, it is affected by the current, number of turns, and number of turns and the amount of current. So option D is also wrong. So option B is correct. Okay, and also remember that a solenoid is a electromagnet. A solenoid is an electromagnet. That means until and unless the current flows through the coil of the solenoid, it will not act as a magnet. So option B is the only correct answer. 23, not 23, 23, the third part. 23. Let's see the question. The magnetic field produced inside the solenoid are similar to that of a bar magnet. Okay, a bar magnet. Yes, that is correct. Magnetic field lines are produced similar to bar magnet. Yes. A straight current carrying conductor? No. A circular current carrying loop? No. Electromagnet of any shape? No. Okay. See that if you change the shape of the solenoid, the magnetic field lines shape will also change. So option D is not at all correct. So the only correct answer is A. So 23 is A. Let's see the next question. 24. After analyzing the graph, a student write the following statements. Let's see what conclusion the student has made. First option, 1. It's not option 1. The magnetic field produced by the solenoid is inversely proportional to current. So the first option, he says it is inversely proportional to current. See the graph? No, it is directly proportional. B is directly proportional to I. So 1 is not correct. So I'll write here just 1 and I'll cross mark. Next 2. What about 2? The magnetic field produced by the solenoid is directly proportional to current. Yes, that is correct. From the graph I can say that. 3. The magnetic field produced by the solenoid is directly proportional to square of current. No. If it is proportional to square of current, then the graph would look like this. That is not the case here. So it's a straight line. No, the third one is wrong. And let's see the fourth one. The magnetic field produced by the solenoid is independent of current. No, absolutely wrong. It is dependent upon the current and is also dependent upon number of turns. So which is the correct answer? The correct answer is only 2. Only 2 is correct answer. And if you see the options, it is in the option D. Option D is only correct. Only 2 is correct. Only 2 is correct. So that was question number 24. Okay, question number 20, part 4. Next, the last question of the section A. 20, part 5. From the graph, deduce which of the following statement is correct. So you have to tell me from the graph which of the following statement is correct. A. For a current of 0.8 ampere, the magnetic field is 13 millitesla. So how do you do that? You have to see that, right? 0.8, 13 millitesla. Yes, that is correct. So A is correct. But I will not lock A unless I read all the options. For larger currents, the magnetic field increases non-linearly. Yes, that is correct, but we can't say that from this graph. Okay, that is true, but we can't say that from this graph. So I'll consider that as wrong for now. Let us read more options. For a current of 0.8 ampere, the magnetic field is 1.3 millitesla. No. C is wrong. There is not enough information to find the magnetic field corresponding to 0.8 ampere. That is also wrong. For 0.8 ampere, it is 13 millitesla. That can be found out from the graph. So only option A is correct. So answer is option A. So that is the end of the section A. So I hope you have learned something. You have learned how to answer and how the concepts. Okay, I think you have learned some concepts, some more in-depth concepts while answering these questions, while watching the video, and you might have understood how the questions will be asked in the board. Right? So you have to read each and every line of the textbook if you want to score full, and not just reading will make, but your analytical skills will work here too much. Okay, you have to make your analytical skills work. So I have enjoyed making this video, and if you have also enjoyed listening to this video, please like the video and share it with your friends. So let's meet in the another video where we'll be discussing the section B. Until then, bye bye and tata.